Yeah, let's go. So why do we need to talk about this? Let me show you a normal canister and the problem that we face. So I have one canister, it's a counter, and it's called example upgrade. Let's see. So we have a counter, we can increment it, and we can query it. So 1, 2. And now we want to add a method. What we want to make is a multiply counter method, which takes an argument, a natural value, and it will multiply the counter by n. So counter is equal to counter multiplied by n. And we redeploy because we have a new function. And now we have our new function, but if we take a look at the counter, it has been reset to 0. So every time we upgrade our canister, we will reset the value of our counter, which maybe we don't want. We don't want to always start at 0. We want to keep track of it. So to fix that, you can use the stable keyword. This will preserve the value of the counter across upgrades. So I need to upgrade it. Now it's stable. And now I can play with it. So increment the counter, 1. I will multiply it by 10. So our counter is now at 10. And now if I want to maybe add counter, so this will add a value to our counter. This time we still have our counter that is, oh, wait. We don't have the, looks like this one is not, okay. Ah, okay, that's it, we have it. We have our new function and we have reset the counter. Why do we have reset the counter? Okay, I think it's because stable was not there before. Okay, yeah. So now if we do increments, then multiply, should be at 10. And now let's say public function reset counter. I did not save. So the problem is that I did not save the first time, and so when I upgraded, there was not the stable keyword, but now it should have been the case. And okay, so we have the reset, and also this has not been reset. So what does stable mean? Well, stable means that your variable is stored in stable memory. And so uh, here, stable memory and heap memory. So It's important to understand our canister has two types of memory. The first one is the heap, which is always going to be 4 GB because it uses a runtime called wasn't-time, which we can find here. This is the runtime of the canister. And right now it's 32 bits. So it's addressing the memory on a 32-bit standard. So it's not 64 bits. And as long as it's not increased to 64 bits, the limit will always be 4 GB. The heap, you can think of it as a pile of memory that is available for the canister. And the heap is the fastest memory available. So it's directly accessible. It's the fastest one, but it's also the one that is reset upon upgrades. Stable memory is another memory of the canister. And this one is a little bit slower to access, but it's not reset during upgrades. I think the stable memory now is up to 100 GB, so this is not up to date. It's not 48 GB anymore, it's even more. And stable memory, stable memory is super important if you want to store a large amount of data. So everything in stable memory will survive upgrades. It's a little bit slower, but it's not I'll say it has been increased by a lot. Like it was already in the beginning, it was very, very slow, but now it's almost as fast as the heap, and you can use it safely. And so we have this concept of stable variable, and those variables in Motoko, they are automatically stored in the stable memory. So this is stored in the stable memory, and you don't have to worry about it. So this is really good, and you should use the stable keyword as much as possible. Now, unfortunately, not every type can be stable. That would be too easy if we could just add stable everywhere. For example, one example of a type. So let's say we want to store some users. So this is how you define your hash map, as we've already seen multiple times. And we are not able to do this. It would be very convenient, but it's not possible. Variable users is declared stable, but as non-stable type. This is because a hash map is a class, and a class cannot be declared stable. So just like a class cannot be declared shared, it cannot be declared stable as well. So you have a lot of types that are stables. So stable types are the types that can be declared as stable. Like you can declare a nat stable, a text stable, int stable, nat8, nat16, and so on. Float, character, boolean, arrays can be declared as stable, but not an object that contains method. A class cannot be stable. That's why hashmap and premap cannot be declared as stable structures. So it's possible to rewrite how those structures are created. And for instance, there is, if you look at maps, you will see a lot of stable structures. So, for example, map. Map is a stable hash map. It has been created by the community. So you can see the code here, and it's a stable hash map. So it's essentially a different implementation for hash map that can be declared stable. You can see map is stable. And so by default, yeah, by default, it's possible to rewrite all the structures to make them stable, and I believe that's what we are heading towards in the next few months. Most of the bigger projects uses stable structures because you don't have to worry about upgrades. You can be safe and you can have a lot of memory, a lot of a lot of data in memory. So stable structures are very interesting. You also have stable buffer. It's a buffer that is stable. And if you want to check all of them, I think stable B3. What else? Vector, I believe, is stable as well. You can take a look, maybe if you do stable here. Yeah, you can see all the stable data structures that are being built at the moment. So there are a few of them. And I think we will see more and more of them. So what if you don't want to use a stable structure? So let's say you really want to use the hash map. You really want to use the hash map here. In that case, you can do a little trick. So you can use what's called post and pre-upgrade. Those are system functionality, so pre-upgrade. This will always run before your upgrade, and this will always run after your upgrade. And so what you can do is do stable variable users entries. You define this as an array with a tuple, principal, and user. And this can be declared stable because this is an array, right? And what you do is that, let's move that up here. So this is everything related to the counter is here. This is our user functionalities. Before upgrading, you are going to store everything from the hash map into the array. So you can do users entries is assigned to iter to array of users dot entries. Essentially, you take all the entries inside the hash map and you store them inside the array. For that, you need to import the iterator, of course. And then whenever you are after upgrading, you can do something like a function that will, for example, that will take all your user entries. So for principal and user in user entries dot values, you will do users dot put principal and user. And you don't really need that. You can just do that like this. Post upgrade. So essentially, take the data that is here, put it here in a stable structure, perform the upgrade, and then put it back into the structure. And this will be safe because during the upgrade, it will be inside, the data will be inside this structure, and so it's preserved across upgrades, of course. It's not what I recommend. It was the only way to preserve data across upgrades. Like when I started, I think like 1 year ago, it was still the case. But now we have a lot of stable structures that are coming our way. So I would recommend, if you are working on a production application, to really take a look at the stable structures. I recommend the stable map. So map is good. I'm using it at the moment, and it has a lot of benchmarks and tests behind it. So I'm pretty confident using it. And you can also take a look at the others. I would recommend to go directly with a stable structure. Pre and post upgrade, I think, will be less and less used, especially because this is expensive operation. There is a limit to how many cycles you can consume for the pre-upgrade and the post-upgrade. And so you could be in a situation where you have so much data that this will trap and you won't be able to upgrade. So if you have a trap, so if something in your pre-upgrade trap, so this is, of course, you wouldn't do that, but a trap could occur because you have an array that is index that is, sorry, you have an array out of index, you divide by 0, you have an issue with your memory, something corrupts your system, and you have a trap. Let me show you, let me show you what a trap in the pre-upgrade means. And you won't like that because it's very problematic. So we have upgraded, and I don't think I saved, I'm not sure. Let's see. Okay, so we have upgraded. Now we have this code in the canister. And let's say public function get users. Return users iter.toArray. Okay. Let's see what happens if I try to upgrade. So I did not save, so it did not upgrade. Yeah, if you don't save, sometimes it will consider that you are trying to install the same code, and so it says module is already installed, and it doesn't even try to upgrade. Okay, so now failed while trying to install. Canister trapped explicitly, assertion failed, of course, here. And now you are in a very complex position because if you want to upgrade, if you want to fix your problem, you need to upgrade, right? We need to remove that if we want to fix our problem. But how can we upgrade if every time I try to upgrade, in my pre-upgrade that will be executed before the upgrade, there is a trap? You can't, so your canister is basically bricked and you won't be able to get it back. There is nothing you can do. So those functions pre-upgrade and post-upgrade are very dangerous. That's why I would recommend to use stable structures inside instead of that. So we've talked about the stable memory, the heap memory, stable variables types, pre and post upgrades, and also potential issue with that. Now I want to talk about something that is also an issue when you upgrade, but not about the memory. It's about your interface. So let's say you have a method, getCounter. You publish your canister, and then you have other developers that build on top of you. They want to use your counter for some reason. And in their code, they call getCounter or multiply counter and so on. Now, let's think about what would happen to those developers if I remove this method. And what would happen to those developers is that they would try to call a function that is not on my interface anymore. And so that's why you will often see those messages. Candid interface compatibility check failed. You are making a breaking change. Other canisters or front-end clients relying on your canister may stop working. So this is not as bad as losing your memory. You will still be able to, upgrade your canister. But in this case, if we remove getCounter and we have someone that has been, consuming our method, using it for some reason, either a front end or another canister, then we are essentially modifying the interface without, and that could lead to problems for other developers. So you have the choice to proceed or not. We will proceed. And of course, we cannot upgrade anymore. So I will I'll stop my. So I've stopped the replica to fix the problem. But that's not the only thing that could happen. Maybe you will change. You will not remove the method, but you will change the method. Maybe you will, add another argument. Like, this one is not so good, but maybe here you will add an argument. Let's say you change this to this. And this is also a breaking change, because when someone will use your canister, they are going to call this method, and for them, the type of the method is, there is no argument here. So they are not going to provide an argument, and this will, of course, this will not work. Nothing is, I mean, not everything is a problem. You can still upgrade, but you have to be smart about it. For example, what you would be allowed to do, and there are a lot of things that you are allowed to do. There is a complete list in the Candid explanations, because it's related to Candid. For example, you would be able to do something like this. Adding an optional type to your interface is not a problem, because if you do that, by default, when your client will call the canister, it will automatically add a null value for every optional field. So this is taken care by the system, and you don't have to worry about that. You could also remove arguments. So if you actually remove arguments, it won't break clients, because they will just the system will just consider that if you remove the arguments, they will just be dropped. You could also change this to an int, for example. That would be a good example. Let's say you change this to an int. So instead of a nut, you decide that your counter is going to be an int. This is not a problem. You can do that. Where is the problem? Okay. Because every nut is also int. Yeah, there is a breaking change because I have removed a method, but it's not related to the change I've made. So changing a nut to an int is not a problem, because every nut is also int. And so if my client or another developer sends me a nut, it's still going to be valid here. So it's going to be interpreted as an int. So as you can see, there are things you can do and things that you cannot do. And if you want to, get a more complete view of what you are able to do, what you are not able to do, you can read a bit more about interface changes. So this is explained here. And yes, you can read about Candid. Is there? Yes, so this is like complex. I mean, a bit more complex, but you can read this. It's from one of the creator of Candid that wrote a blog post a few time ago, and he explains everything that you can do with upgrade and everything that you cannot do. There is a concept of subtype and supertype, and so there are some operations that are ignored, and everything is part of Candid. So that's why we have Candid. That's one of the main reasons that Candid was invented, is to check the changes that you do to your interface And if some changes are against the rules, or like it will break some of your clients, you will receive a message of a warning message. And so, as you can see, we have when you upgrade a canister, DFX will automatically download the metadata of the old canister and compare it with your new module. So we can take a look here. There is .old. So this is the candid file for your old canister, and this is the candid file for your, so this one, for example. This is the candid file for your, it's not the candid file, it's the stable, it's your stable signature. This is the stable signature here, and this is the stable signature here. And essentially, DFX is going to compare the two files, and it will check if there is an issue, and it will warn you, and it will do the same with your candid interface. If you change something that in a matter that is not authorized, it will also throw a warning. And that's really good and really useful. And yeah, the verification that is performed by DFX doesn't guarantee that the upgrade will work. It just says if the upgrade works, you will not lose your data or you will not break existing clients. So yeah, let's see if we have a few questions. So there is no default value for an argument. Example, breaking change on increment counter. Something like increment counter. I don't believe you can do, no, you cannot do this, like, you cannot specify a default value. If you want to do that, you would need to specify a type like this. And essentially, if the specified value is null, then the counter this will act as a default value. So if someone calls this canister method add counter without specifying a value for n, then by default the system will interpret that as a null value, and so you can specify a default value here. Oops, that's maybe not what we wanted to do. It's more like this. And yeah, that's how you could implement this default value behavior that you mentioned. Would that be the best practice to avoid breaking changes? I mean, it depends on what situation you are in. I haven't seen too much people use this. Use this for a situation like this one. I don't think you would use this. Hmm. Depends on your situation. I would need to have more specific situation to answer. There is, does the pre-upgrade and post-upgrade have any timeout if the database is huge? Yes. So that's why I was saying those are dangerous, even though you can use them. Those are dangerous methods. They don't have timeout in the sense of a specific time. It's about how many WASM instructions, how many cycles you can consume in the post-upgrade and pre-upgrade. And there is a limit of the number of instructions that you can run in those methods. I don't remember the numbers. It's pretty high. Like you would need to really have a lot of data before you run into issues, but I know that it's possible and it happened to some projects. So basically, yeah, if you're already doing so much operations, that would be an issue. Isn't that pre-upgrade hack expensive? Yes, it is expensive. We basically loading and then cloning a hash map. Yep. Stable meaning serialized to stable memory for you. What about a type optional? I guess. Yeah, this can be stable. Yeah. So we just need to do that. And then of course, well, this change everything. But yeah, this can be a stable type. What happens if we create custom user objects and then we add a new field? Yes, this is a good question. This is not a problem to add fields like I don't know, role. You could add fields. What it would be a problem is removing fields. Wait, let me see. Isn't it a problem to add fields actually? Well, actually, I'm not so sure what I'm saying right now. Can you just add fields like this and it's fine? No, it's not actually. It's not fine. That would be breaking change. Um, let's see. If I do this. Yeah, so you will lose your data if you do that internally. For so there are two answers to this question. Like if you create a new type, for example, and you do this, then it's okay for your clients because they will send the old user. So this one, and then this one will be by default fill out with a null value. But if you're talking internally, this will cause an issue to your stable structure. Like as you can see, compatibility error, stable variable user entries of previous type variable principal user cannot be consumed at new type. So you would actually lose your data. Yeah. Yes, you would have to do a migration. You would have to do a migration, yes. But you could add optional fields for sure. Like I think this wouldn't cause any issue. If you feel that the field that you are adding is optional, you wouldn't cause any issue. Looks like the system doesn't agree with me. Mm. What I know that you can do, I know that you can add variants. So if you have a variant, like you can always add new variants, like you can always add more. This will not be an issue, but for the objects, if you add new fields, Yeah, this is an issue. I'm surprised that the stable the empty like the optional field, adding an optional field is a problem. Uh, yeah, there is a good topic on there is a good topic on it. So losing data when upgrading records, essentially it's saying the same as we have just tried. So if you have an entry like this one, and then you try to add another field, when you upgrade, you lose all your data. There is a solution, you have to add optional fields, then data won't be lost, but apparently, actually, that quick solution will not be recommended going forward, since it relies on an implementation detail of the serialization mechanism to work. Once we start statically checking upgrades by checking the types of the stable variables according to Motoko subtyping rules, this will be rejected. Although it happens to work now, please don't do this. Promote an existing stable variable to a Motoko supertype. Add a new stable variable. Okay. So I think there is someone that migrates. Okay, no. Ah, okay, this is a migration, I think, pattern that is used here. I will post the links. So this one and this one. So I guess this is a kind of a template to migrate from. I wish there was more documentation though. See source migration for migration example. Let's see. Yeah, apparently, I mean, that's how I've done it as well. When I needed to migrate my data from like a type to another type, I've always copied my data and then put it back, which is, I agree, not the best thing to do if you have a lot of data, if you have a large data set. I don't know if there is a better solution right now. I wouldn't expect actually a better solution. Can we store a PostgreSQL or other JSON database in a canister? Yes, nothing prevents you from using JSON type of data. So I think there are even some libraries. Yeah, you have some JSON library, and I think there is no, but there is CanDB that works on SQL, PostSQL database. So by default, you will need to, you will need to serialize your data, but you can totally store, I mean, you can store whatever you want. Do we have oops. Do we have more questions on the upgrading of canisters? What the heck is a Motoko super type? Yeah, okay. Uh, I will check it out before answering because I think it's related to what I've said before, like super type and subtype for the upgrades. We will need to look at the language reference. Mhm. So subtyping, so not super type, but subtyping. Uh, so Motoko is using structural subtyping, which means that uh, is it dead? Structural. I will send this document in the chat first. So this is not what I was looking for. Mm, so basically, this is explaining a little bit about subtyping. So for the object subtyping in Motoko, um, you so here objects have types and objects with so object have fields and object with more fields are less general. There are subtypes of types with fewer fields. So subtypes, the object, so this one is a subtypes of this one. This one is very general, this one is middle general, this one is least general. So if a function expects to receive this object, anyone here will work. Any one of those objects will work. But if a function expects to receive this one, it won't work with this one and this one. And yeah, that's basically what subtyping is for objects. And Motoko uses structural subtyping, not nominal subtyping. So in Motoko, two objects are equal when they have the same structure, not the same name. Like, for example, I think I could show you a quick example of that here. So let's say we define a type post for a blog. Time.time. So we have three fields in our object. We have the text, the blob, and the time.time. And someone else define another type, which equals message, another developer. And he actually uses the same structure as us. Just not the same name. Any function that uses a post could be used with a message, and any function that uses a message could be used with a post. Those types are equal, even though they don't have the same name. And that's what subtyping is, structural subtyping is. Yeah, so in nominal typing, the question of two types equality depends on choosing consistent globally unique type names. In Motoko, the question of two types equality is based on their structure. So this is equal, this one is equal to this one because they have the same fields. Doesn't answer what is a super type, but I guess that's so. two classes, so it's also a case for the classes. If two classes have different names, but they have equivalent definitions, they will be type compatible. And well, I guess supertype is the opposite of the subtypes, so. This is probably better explained in the Candid explainer. So those are relations between types. This relation is written like this. This is a subtype. So it's in the case of Candid, we use subtypes for checking upgrading, like upgrade, safe if the upgrade is safe or not. It is safe to upgrade a service to a subtype. So A2, this is our service A1 and A2. And so A1, we have a function that takes yeah. So upgrading this one to this one is safe. I often, in small examples, I often use nat and int. Yeah, that's the example I've taken because every nat is also int. So every natural number is also int, but some ints are not nat, the negative ones. We say that nat is a subtype of int. So a subtype is a type that is contained in the type. And the opposite is a supertype. So nat is a subtype of int, and int is a supertype of nat. And that closes my explanation. I think yeah, I'll read a bit more about subtyping and supertypes. I don't. Yeah. Okay. Well, this is super interesting. This blog post is super interesting if you want to dive into it. It's about Candid, but Candid and Motoko are very, very close. So yeah. Okay, so that's it for the session on upgrades. Thanks everyone for joining. We have our session in 2 hours about building the level 4 together. So this one, and then we have a session with a guest. So we have Isaac coming up, and we will talk about what can be built on ICP. So more generally than DAOs, we will talk about some ideas and some projects that are interesting in the ecosystem, and maybe that will give you some ideas. Okay, I see everyone. Bye.